Dear students, welcome. Today we will study and analyze Thevenin's theorem. Let's begin with its definition. Thevenin's theorem states that any two-terminal linear network or circuit can be represented with an equivalent network or circuit which consists of a voltage source in series with a resistor. It means that the entire circuit is needed to be simplified and it must have only a voltage Thevenin source, a Thevenin resistance and its load resistor. The equivalent circuit is known as Thevenin equivalent circuit. A linear circuit may contain independent sources, dependent sources and resistors. If the circuit contains multiple independent sources, dependent sources and resistors, then the response in an element can be easily found by replacing the entire network to the left of the element with the help of Thevenin equivalent circuit. Thevenin equivalent circuit resembles a practical voltage source. Therefore, it has a voltage source in series with a resistor. Considering this diagram, here we have two-terminal linear circuit, points A and B and load. This is your main circuit which is connected to a load, and here are your mentioned points. This circuit can also be resembled as Thevenin voltage source, which is represented as V Thevenin, R Thevenin or Thevenin resistance, and the load. This load will be a resistor. Thevenin's equivalent circuit resembles a practical voltage source. Therefore, it has a voltage source in series with the resistor. You can see that it has a voltage source and there is a resistance in series. The voltage source present in the Thevenin's equivalent circuit is known as Thevenin's equivalent voltage or simply Thevenin's voltage, represented as VTH. The resistor present in the Thevenin's equivalent circuit is known as Thevenin's equivalent resistor or simply Thevenin resistor and is represented as RTH. There is a specific method to follow in order to solve a circuit with the help of a Thevenin theorem. Therefore, you are required to follow these steps in order to find Thevenin's equivalent circuit when only the source of independent type are present. Step 1 is open the terminals of the circuit with respect to which the Thevenin's equivalent circuit is to be found. Next step is find the Thevenin's voltage VTH across the open terminals of the circuit. Step 3 is find Thevenin resistance RTH across the open terminals of the circuit by eliminating the independent sources present in it. Step 4 is drawing the Thevenin's equivalent circuit by connecting a Thevenin's voltage VTH in series with a Thevenin's resistance RTH. Now we can easily find the response in an element that lies to the right side of the Thevenin's equivalent circuit, which is usually the load. There is a second method. Here are the steps to follow. You need to follow the steps in order to find Thevenin's equivalent circuit when the sources of both independent type and dependent type are present. Step 1 is open the terminals of the circuit with respect to which the Thevenin's equivalent circuit is to be found. Step 2 is find the Thevenin's voltage VTH across the open terminals of the circuit. Step 3 is finding the short circuit current ISC. SC stands for short circuit, by shorting the two opened terminals of the circuit. Step 4 is finding the Thevenin's resistance RTH by using the following formula. RTH is equal to VTH divided by ISC. Step 5 is drawing the Thevenin's equivalent circuit by connecting a Thevenin's voltage VTH in series with a Thevenin's resistor. Let's proceed to our example to understand the Thevenin's theorem. Consider the following circuit. This has a 20 volts voltage source connected with a 5 ohm, 10 ohm and 10 ohm resistor having a current source of 4 ampere and a load resistance of 20 ohm. Now we need to find the current which is delivered to 20 ohm resistor. Therefore, in order to find the Thevenin's equivalent circuit to the left side of terminals A and B, that is terminal A and B, we have to simplify this entire circuit. Therefore, we should remove the 20 ohm resistor. This resistor should be removed from the network by opening the terminals A and B. We will just disconnect this resistor from this point. The modified circuit diagram is shown in the following figure. This is how our circuit will look like. It has a voltage source, a current source and 3 resistors. Now we don't have our load resistance. Here we have our V Thevenin and we will connect our R Thevenin here after calculation. Now first of all we are required to calculate the Thevenin's voltage. For that there is only one principal node except the ground in the above circuit. This is our principal node. Why? Because current is entering here, current is leaving here and current is entering here again. This is in this direction, in upward direction, so it is entering. So 2 currents are entering into the node and 1 current is leaving. Keep this diagram in mind and let's solve our circuit. So we will apply our nodal analysis method here. For that, the node voltage V1 and Thevenin's voltage VTH are labeled in the figure. You already seen that where V1 was and where VTH was. VTH was lying at the end of the circuit on the right side where V1 was our node voltage. V1 is the voltage from node 1 with respect to the ground and VTH is the voltage across 4 ampere current source. As I already mentioned, VTH is lying to extreme right side where V1 is our node voltage. The nodal equation at node 1 will be V1 minus 20. 20 is the source divided by 5 plus V1 divided by 10 minus 4. As I mentioned, this can be simplified as we take 10 as LCM, so we multiply V1 by 2 and 20 also by 2, so we get 2V1 minus 40 plus V1, because here 10, so we write it as it is, and we multiply 4 by 10, so we get 40. After simplification we get 3V1, 2V1 plus 1, 3V1 minus minus, this will sum up, so minus 80 is equal to 0. This can also be written as V1 is equal to 80 by 3 volts. So we get V1 equal to 26.66 volt. Now the voltage across series branch 10 ohm resistor will be V10 ohm is equal to minus 4 multiplied by 10. So that will be minus 40 volts. Minus 4 is our current and 10 is our resistance. So our voltage will be minus 40 with the help of Ohm's law. There are 2 meshes in the above circuit. which is already illustrated. So the KVL equation for the mesh 2 will be V1 minus V10 ohm minus Thevenin is equal to 0. We got our V1 as 26.66 ohm and V10 ohm is minus 40 volts. So we will substitute the values. So we will get Thevenin is equal to 26.66 minus into minus 40. So we get our Thevenin is equal to 66.66 volt. Now it's time to calculate the Thevenin resistance RTH. For that we will proceed as we will short circuit the voltage source and open circuit the current source of the above circuit in order to calculate the Thevenin's resistance RTH across the terminals A and B. Now what we will do is we will disconnect the supply and also short circuit the current source. So what we will do is we will disconnect the source voltage and current source and then place our ohmmeter for measuring R Thevenin. R Thevenin is basically R equivalent. Therefore, the modified circuit diagram is shown as this is how we remove our voltage source and current source. Now our Thevenin is in this direction. So the Thevenin resistance across terminal A and B will be R Thevenin is equal to 5 multiplied by 10. This and this are in parallel and it is in series with the other resistor. So 5 multiplied by 10 divided by 5 plus 10 plus 10. So we get 10 divided by 3 plus 10. We get 40 divided by 3. The R Thevenin is equal to 13.33 ohms. This is the Thevenin equivalent circuit and is placed to the left terminals of A and B of the circuit which was given. Therefore, the circuit diagram will be as V Thevenin, which is 66.66 volt, R Thevenin, which is 13.33 ohm, and 20 ohm load resistance. This is our final circuit after simplification through Thevenins theorem. The current flowing through the 20 ohm resistor can be found by substituting the values of V Thevenin, R Thevenin and R in the following equation. I is equal to V Thevenin divided by R Thevenin plus R. This is final equivalent resistance of the circuit. So we get our current as 200 divided by 3, which was our voltage, 66.66 plus 13.33 plus 20. So after simplification we get our current as 2 ampere. Let's now proceed to our simulation. We will go to falstad simulator. However, you are required to remember all steps because we will perform simulation in stepwise. Let's go to falstad. Here we are in our falstad simulator. We will first clear the screen. Now we will start building up our circuit. We had 3 resistors in our circuit. So we will place 3 resistors. First resistor was of 5 ohm and the next 2 resistors were of 10 ohm. Now that we have changed our resistors, now we will place our load resistance. Our load resistance was of 20 ohms. Now we will connect the circuit through wires. Our circuit is now connected. We will place a long wire here for the connection of voltage source. Now what we will do is go and place our voltage source from input in sources. Our voltage source was of 20 volts. Now our circuit is complete except that we have to place our current source. So we will disconnect it here and place our current source right here. Remember that our current source was in upward direction. So you have to keep this direction in upwards and change its value to 4 ampere. Now connect this circuit with wires. Now the circuit is almost complete except that we have to add our ground. So we place our ground here. Now here we have our first step. Our first step was to disconnect the load. So we disconnect our load. This is our resultant circuit. Now we are required to find V1. This is our point V1. We have to find our voltage here. For that we are required to place 3 voltage meters, one for this resistor, for this resistor and for this resistor. So let's go into output and labels and place 3 volt meter as required. Here the current is flowing in this direction, so we will place our voltmeter in opposite direction. Now we will connect our voltmeter with the help of wire. Now you can see that we have our V1 voltage as 26.66. This is our V1 point and we have our voltage as 26.66 here, right? And we have minus 40 volts at our this point. We are 10 ohm as minus 40 volts. This is as per our calculation. Now what we can do is find our Thevenin as well. For that we need to connect our voltage source right here and we will get a value of 66.66 volts, right? So we will go draw output in labels and place our voltmeter here. You can see we have 66.66 volts here. Now we get our Thevenin. This was our Thevenin. We have our Thevenin equal to 66.667 ohms. Our next step was to calculate or find the Thevenin. For that we need to cut or disconnect the voltage source, as well as we need to open the current source. For simplification, we will delete all of the voltage meters. So that we have no extra components and wires in our circuit. Now our circuit is simple. Now what we do is we just connect this. This is how we short it, and now we will place an ohm meter here for getting our Thevenin. So we'll go to output and labels and place our ohm meter right here to get our Thevenin. So our Thevenin is 13 ohms, which is exactly same that we got in our calculation. Now we will place the Thevenin here, R Thevenin here, in our load here. We will simplify the circuit. So we clear the entire circuit as we need to build our new circuit. So for that we are going to place two resistors. This is our R Thevenin and its value was 13.33. So we put it 13 and here we put our load resistance and its value was 20 ohm. Now we will go to draw out inputs and we place our voltage source here, which was 20 volts. Now we will connect the circuit all together. Now understand this circuit. This is our Thevenin, which value is 66.66 volts. It's 13 ohm R Thevenin and this is load resistance which has value of 20 ohm. We will add the ground for getting the perfect readings. So now we will add ammeter at this point to see what is our current flowing through load resistance. Here we have 2.02 ampere, which is exactly the same that we got during our calculations. So this is how you verify Thevenin theorem through simulation. This was all about simulations. Now it's time for your home task. You have to verify Thevenin theorem for the given circuit. You need to do all necessary calculations and you have to perform simulation as well. This is your circuit. A 48 volt source is connected with 3 resistors and an RL. You have to find current for the RL. This was all about today's lecture. If you have any queries, feel free to ask. Thank you.